Hello friends, we shall look at the product rule as one of the methods of differentiation. And the product rule states that if y is equal to uv and u and v are both functions of x, that is u is equal to u of x and v is equal to v of x, then dy dx is equal to u dv dx plus v du dx. So this is the product rule of differentiation and is always used to find the differential coefficient of product functions. Okay, now let's look at few examples. Example number 1. If y is equal to x squared ln x, find dy dx. All right. Now, here we are going to call x squared u and ln x v. So we now say let u equal to x squared and v equal to ln x. The first parameter is always u, while the second parameter is v. All right. So now let us find the differential coefficient of u with respect to x. So du dx is equal to, of course, we know that the du dx of this function is 2x, as I said in our previous lecture. And here, the v dx is equal to 1 over x. The differential coefficient of ln x is equal to 1 over x. I said all these things in our previous lecture. Okay, now we now combine all these parameters, but we know that dy dx is equal to u dv dx plus v du dx, which is equal to u is x squared, you put it there, x squared multiplied by dv dx is 1 over x, then plus v is ln x multiplied by du dx is 2x. All right, so from here, this x, we cancel one of the x here, and we are left with x times 1, and x times 1 is equal to x, plus here we have 2x ln x. And since x is common to the both, we now factor out x. So this is equal to x into what remains here is 1 plus what remains here is 2 ln x. And that is the differential coefficient of y equal to x squared ln x. Okay, let's look at another example. Number 2, if y is equal to, maybe say 2x sine x, find dy dx. All right, so as usual, we say let u equal to 2x and v equal to sine x. So when we differentiate u with respect to x, du dx is equal to 2 and dv dx is equal to, when you differentiate sine, the result is cos. Okay, we now combine, but we know that dy dx is equal to u dv dx plus v du dx. All right, so dy dx is equal to, u is 2x, you put 2x there, multiplied by dv dx is cos x, then plus v is sin x, multiplied by du dx is 2. So this is equal to 2x cos x plus 2 sin x. Okay, now since 2 is common to the both, you factor out 2. So this is 2 into x cos x plus sin x. And that is the answer to that very problem. Let's look at another question. Question number 3. Says that if y is equal to, let's say, 2x plus 1 multiplied by 3x minus 2, find dy dx. Okay, now we now say let u equal to 2x plus 1 and v equal to 3x minus 2. So when we differentiate, du dx is equal to, when you differentiate 2x plus 1, the result is 2. And dv dx, when you differentiate this, the result is 3. Because we know very well that there is 1 here. When that 1 multiplies 2, it is 2. And when you subtract 1 from that power, it becomes 0. And x raised to power 0 is equal to 1. Here, the derivative of 1, which is a constant, is equal to 0. The same thing applies here. Okay, now we combine the answers. So, but we know that dy dx is equal to u dv dx plus v du dx. And this is equal to u is 2x plus 1 multiplied by dv dx is 3 plus v is 3x minus 2 multiplied by du dx is 2. Okay, now this is equal to when we use this 3 to multiply everything inside the bracket, it becomes 3 times 2x will give us 6x plus 3 times 1 is 3, then plus 2 times 3x will give us 6x minus 2 times 2 is equal to 4. And when we collect the like terms, 6x plus 6x will give us 12x. Now 3 minus 4 will give us minus 1. And that is the differential coefficient of this very function. And finally, let's look at another problem. Number 4, if y is equal to, maybe say, e to the x and x, find dy dx. All right. Now we now say let u be e to the x and v be tan x. Okay. Now when we differentiate, du dx is equal to, I said in a previous lecture that this function behaves like a small god. It does not change no matter the number of times you differentiate it. So the u dx of e to the x is also e to the x. And the v dx, when we differentiate tan x, the result is sec squared x. So when we combine, but we know that dy dx is equal to u dv dx plus v du dx. Okay. Now, dy dx is equal to u is e to the power x multiplied by dv dx is sec squared x plus v is tan x multiplied by, and du dx is e to the x. All right, so this is equal to e to the power x sec squared x plus, when this one multiplies, e to the power x tan x. And since e to the power x is common to the both, we factor it out. It becomes e to the power x into, what remains here is sec squared x, and what remains here is tan x. And that is the differential coefficient of e to the power x tan x. Finally, let's look at this problem, maybe number 5. If y is equal to maybe sine x cos x, find dy dx. Okay, let u be sine x and v be cos x. Okay, now du dx is equal to, when you differentiate sine, the result is cos, and dv dx is, when we differentiate cos, the result is minus sine. Okay, now, but we know that dy dx is equal to u dv dx plus v du dx. And this is equal to u is sine x multiplied by dv dx is minus sine x plus v is cos x multiplied by du dx is cos x. Okay, sine x times minus sine x will give us minus sine squared x plus cos x times cos x will give us cos squared x. So we can decide to place this one first before this one. So we now have cos squared x minus sine squared x. And that is the differential coefficient of sine x cos x. Thank you very much for your audience. Please don't forget to follow and subscribe.